So let's just talk about the tree data structure. So a tree is a non-linear hierarchical data structure, and it is used to store and organize data very efficiently. So the tree is different to the linear data structure that we have talked about earlier. So in linear data structure, we store the elements sequentially one after another. Like in example, we have the array. So in array data structure, we store the elements one after another in consecutive memory locations. And also we have the linked list. Here all the nodes are connected using the link. And also we have the stack. In stack we store the elements one on top of another. Also we have this queue. So in queue data structure we store the elements one after another. So all of these are the example of the linear data structure, and they store data sequentially. Now the tree data structure is very different than this linear data structure. Tree data structure allows the branching where one node can have multiple child nodes, which forms a hierarchy. Like an example, here we can have one node and the node can have branches. That means this node can have multiple child nodes. And again, the child nodes can also have their own child, and this way we can have hierarchy of nodes. So this topmost node will be the root node of this tree, and the node which has one or more number of childs, that will be called the parent node. Like an example, this can be one parent node because it has two child. This can be one parent node because it also have multiple childs. So these are called the parent node. And the nodes that are connected directly to the parent node will be called the child nodes. So here the 4 and 5 will be the child node of this node 2. So these are the child nodes. And also a node without any children will be called the leaf node. So these nodes, they do not have any child, so they will be called the leaf node. So let's now talk about the types of tree that we have. We have the binary tree, we have the ternary tree, and we have the n-array tree. So the binary tree is where each node can have at most two children. So it can have the left and the right child. Like an example, we have the binary search tree, we have the complete binary tree, we have the full binary tree, and also we have the perfect binary tree. And the ternary tree is a tree in which each node has at most 3 childs. So that means it can have left, right, and the mid child. Like an example, we have the ternary search tree, we have the ternary heap, and lastly we have the n-array tree or the generic tree. So it is a collection of nodes, and here each node can have multiple child nodes. Like an example, here we have the B tree, and also we have the B plus tree. So these are all the types of tree that we have. So let's now see how we can implement our tree data structure. So here the tree can be implemented by dynamically allocating memory for each of these nodes. And here each node consists of 3 parts. So the node contains the data, and we have the left pointer pointing to the left child, and we have the right pointer pointing to the right child. So that means to implement the tree, we have to dynamically allocate memory for the nodes, and then we have to connect them with the parent. Now we can do that, either we can use the linked list or we can use arrays. So let's now talk about some of the important application of the tree. So first of all, the tree data structure can be used in case of the file system. So the operating systems use the tree data structure to organize the files and folder efficiently using this tree hierarchy. And also secondly, it can be used for the purpose of searching. So like an example, we have this binary search tree which can be used for fast lookups, insertions and deletions in logarithmic time. And also the tree can be used in case of network routing, so in case of packet forwarding, and to find the shortest path calculations we can use the tree. Like an example, we can use the spanning tree to find the shortest path. So this way the tree data structure provides efficient way to store the hierarchical data and also to improve the search performance. So hope you understand about the tree data structure. See you in the next one. Take care.